Students, you're going to run into some problems like these on the online homework for potential energy diagrams and the kinetics online homework. So I want to make sure you know how to do these, and I want to make sure you watch out for a couple of things that are going to be confusing. And that is that you watch out for the zeros on the particular line here representing the graphs. These two graphs, yours in the online homework, might have different numbers here on the y-axis. So don't copy mine and use them as your own, but keep in mind that whenever there's a zero, for instance, this goes from 50 to -3 and they didn't leave 0 in there for you. That's going to affect you because when you start calculating some of the things necessary for the online homework, for instance, let's just say you're doing this particular problem on the left, and they ask you to tell them what the EA or EA, activation energy, sometimes it might be energy of activation like that. Remember, that's the energy from the reactant all the way up to the top of the hill. So if you're calculating that energy, you need to look at the difference between those two values. In other words, you're starting at negative, right below -20, and if you count these, each line is 10. So we're actually at -30 here, and we're going all the way up to +70, because it's right between 60 and 80. So the difference between -30 and +70 is going to travel to 0, which is 30, and then up 70. So EA or AE is actually 100, look at the scale, kilojoules. So watch out for things like that. What if they ask you on this one to calculate the delta E, delta H, or delta E? Delta H or delta E is the difference between the reactants and the products. So you need to subtract these numbers. So it ends at 40. So it's actually delta H or delta E equals the energy or enthalpy of the products minus the enthalpy of the reactants. So with that in mind, you need to have 40 minus, and notice the reactants are going to be a negative number, -30. So guess what happens when you minus a minus? You're actually a plus, right? So it's actually going to be 40 minus -30, which is +30. So what would be the delta H? 70, right? 70 kilojoules for delta H. So watch out for things like that, sign changes and missing zeros. What about this one over here? If we were asked on this one to calculate EA would be the difference between 50 and -3. So 50 and -3. So 0 to 50, that's 50 plus 3 more. So EA is actually 53 kilojoules. What about EA prime? EA prime or EA apostrophe would be in the reverse direction. So going this way, taking the products and moving toward the reactants. That's EA prime. So EA prime is going to be from -37 all the way to 50. So 50 plus 37 to get that total energy there. So that's going to be 87. So EA prime would be 87 kilojoules. And keep in mind, let's say they asked you to find something like delta E or delta H. Delta E forward and delta E reverse. Remember, they're the same amount of energy. So again, for delta H or delta E, you would be going products minus reactants. So the products here are -37 minus the reactants are -3 minus a -3. So how do you subtract those two numbers? -7 minus -3 actually means you need to add 3, doesn't it? So delta H comes out to be positive or negative? -34 kilojoules. So what does that mean, -34? That means this particular reaction in the forward direction is exothermic. Exo is a negative delta H. So what would, if they ask you for delta H reverse, what would you put for that? Delta H reverse. Delta H reverse means the same amount of energy, except you're starting here. So the products are actually your reactants, and you're going to go this way and follow the curve and end here at the reactants, which are going to actually be your products. So basically what you're going to have is you're going to have the same amount of energy, just the opposite sign. So 34 kilojoules for the reverse. I hope this helps you while you work on your online homework, my friends, for kinetics. Take care.